So I'm awake today, really. So yesterday we had a long day. Some of us went down to the Women in Data and AI conference, and some of you participated online virtually with that. I really liked it. It's not a big conference, but it's a nice size conference, and some good speakers. I really like when we can see how normal companies are using data science and AI and stuff like that. I don't know who went to what talks, but I went to one by General Mills. I try to go to companies that I know have hired our students and done internships in the past because I like to see what they're doing. So I went to General Mills. They make a lot of food products, include a lot of cereals, their breakfast cereal. So they're really interesting talk about how they're using data science to try to categorize and predict you know customers and cereals and their other products and their competitors, and it was really interesting look at that. um Target, I went to the Target talk. That was also very interesting to see how Target uses some. I went to Seagate. Seagate is more of a hardware company. They make hard drives, but again, I was with my daughter, and she was right across from the Seagate office, so she really wanted to see Seagate too. And I have a my nephew works at Seagate there, and so I thought my nephew was the most excited person I knew about hard drives. And then I went to the talk yesterday. That young woman was so excited about hard drives. She was very passionate about hard drives. It was very, very, very good. Very fun to see that she was that interested in us. And I learned some for the architecture class, I think. Oh, what's some new stuff there. So overall, I really liked it. So anyone else have anything they want to say about the talks or anything? I didn't go to any. So, okay. I think they might be online. If I find them online, I'll post them. I want to find the one by Toro because again, Toro has a lot of internships. And you think a lawnmower company, who wants to work for a lawnmower company? But I'm always surprised that's where you find some really interesting work in this sort of stuff is these companies in order to, I mean, they are thriving because they do this sort of stuff. They do data, they manage data, they grow. That's why places like General Mills and Target and Toro and Polaris, I mean, they have good engineers, they make good products often, but they also have the ability to work with data and manage it these days. So we're going to do Unit 10 today. I really like Unit 10 because I think it shows we've been doing all this talking about how we're breaking things in and adding these interfaces, and we might ask, why are we making this so complicated? And at this point, I think we get to see why. We get to see now we have kind of the structure. Why is it so powerful? Why can we do things? And what we see is not that complicated. We've done all this, and now when we change things and do things, it is pretty simple to do some pretty powerful things. And so that's why I like Unit 10. I think we can kind of step back and see, oh, wow, that's really easy to do that now for this. So that's what we're going to hopefully look at today. Um, we are covering, I forgot to bring up the textbook. Let me bring up the textbook here. He's on Zoom. You're not muted yet, so yeah, there. That's good. Thanks. Okay. Um, so we're going to continue our same chapter. Again, we're spending 3 units on this one chapter, but I think it's a incredibly critical chapter here. And there's a lot of stuff packed into this one chapter here. So again, we're still on the single responsibility principle. You remember we started with this one big section of code, one big method. Remember that? And then we broke it down into 3 methods: a read trade data, parse trade data, and store trade. So read it from a text file, parse those lines, and then store that in a database. And so we created methods for each of those objects there. And what we call refactor for abstraction here, or for readability. So, and then we did refactor for abstraction where we added an interface. This is what we did this last week. We added an interface between this, and so each of those methods basically became its own class for this. We take each method and break it up kind of its own class, added an interface between it. This is a pretty common thing to do. In fact, in a lot of code environments, uh, you can take a method and there's a shortcut to say, put this behind a interface or something like that. So often if you find your code, there's these quick actions and stuff like that. Different APIs will have different things. But like this one does this one is saying extract to base class, but a lot of them will have an idea you can break this into an interface and put it behind an interface there. And that's what we did here. We created interface like I trade data provider. This is going to read data in from some source, a text file initially, but then last week we read in from a website, and then we also read in with just a text file stored on the website, and then we looked at a reading in a JSON file from a RESTful API. And we'll actually revisit that. We kind of skimmed over that. So we'll revisit that in the assignment this week. What does that actually do? We had a parser that parsed the data. We don't change that too much here. And then we added a persist interface, which stores the data to a database for us here. So again, we set up that sort of stuff and created that. And now we're going to get down to what we call the decorator pattern here. Uh, What that allows us to do is add functionality to code without actually going in and modifying the original code itself here. Um, we can add code to this easily or add functionality to this for this. What you need in order to do this is you need an interface. In this case, we're just going to call it an I component interface. Although we'll see later in the class, like we have this I persist interface to write to the database. We have an I provider interface to read in the data. Those types of interfaces, we add some information to that we can here. So we have this I component interface, and we have some normal object that implements that interface. And we're going to call that the concrete component here that we're going to work with. And then we're going to add this decorator component. Now, I really don't like this diagram here. So we're going to look at a different version of this diagram. I'm going to go into these notes today and just make this a little. So here's how I view it. I view that we have our main class here, and we have a concrete component, and we have this interface between the two here. And now we're going to add a decorator component in between here. And the decorator component is going to implement the same interface here. So from the main class point of view, it won't be much different because it still is given an object that implements that interface. Whatever methods it calls, it can still call those here through the interface. But we've added this component in between here. So basically, the decorator sits between the concrete component and the main class here. So again, kind of this green line shows how it is originally here. And this pink, purple, I don't know what color this is the new decorator. And again, it implements the interface. And it's going to take the concrete component and call the same functionality through it here. And but we can add some decorations, add some functionality to our concrete component to spice it up here. So basically, we're kind of putting a wrapper around our concrete component. It will do the same functionality, but the wrapper will add some some, functionality, some extra stuff to our concrete component for this.
So what's the difference between this pattern and the adaptive pattern?
Yeah, that's a good question. So it's very similar to the adapter pattern here. In that we create this object where with the adapter pattern, the main class generally doesn't know that it is, and then the concrete component doesn't implement the interface here. We basically the adapter pattern is like the main class through the interface to the decorator component, but the decorator component doesn't use the same interface to the concrete component. Okay, so this is, and again, here we can modify the concrete component and make it implement that same interface. So again, very similar. And again, we see some of the same functionality to that. Uh, yep.
I'm sorry, the question is randomly made over there.
Okay, I'll be here. Uh, so we're going to look at this code from the textbook. So this is this code here. I'm going to bring it in to Visual Studio. So here's it in GitHub. I just clicked on this link. And then I've brought it into here. And we're going to look at it here. So we have some concrete component. It's a very complicated class. I don't know if you'll be able to understand it. It has one method called something, and that says we are doing something. So that is all that this does here. It implements an interface, I component. And this is, again, a very complicated interface. The interface just has one method. Anything that implements the interface has to do something. It has to have a something method. So we have this something method here. And so, yes, our concrete component does have the something method that the interface requires there. Okay. So we have our concrete component, and in our main program, now I've modified the main program a little bit because the original version kind of shows this final version. I've moved it back to this version. So let me show you that. So in the main program, we create a concrete component, new concrete component, and in that we just have it do something there. The concrete component implements, so, and again, when I declare it, I'm declaring it as a I component object. So it's actually a concrete component, but I'm saying it's a static I component object here for this. So I create an I component object. I create a new concrete component, and that's okay because concrete component implements that interface. So it can pretend to be that type of object, that type of interface object. And then again, the only thing it knows how to do is do something here. So that's what we're going to say is something. Now, if I run this, it says you did something. All right, so that's all it does. So that's this green line here. Our main class, we have an I component interface, and we have our concrete component here. So we're going to get rid of that, and we're going to go, we're going to change this and add this decorator in here. So it looks like this. So I'm going to keep this concrete component. I'm going to call it maybe component. Maybe I'm going to call it original component here. And up here, I'm going to call it original. And I'm going to have a new decorator component here. So the decorator component, we pass it in a concrete component. So I'm going to make a new decorator component here. So I'm going to need to declare an object of that type. Let's call it a deco component. And I'm going to say instantiate a new concrete component. Now, a new concrete component, a new decorator component. Now, when I create a new decorated component, it needs the constructor needs a parameter. Let's look at that. So here's my decorated component. Here it needs an object that's going to decorate, a decorated component. So I need to pass it in a component, because the decorated component really decorates something. It needs to know what I'm going to decorate. So I'm going to pass in my original component into that here. So my decorator is going to wrap itself around my original component here. And now I'm just going to call my decorator component do something. So it works the same way as this original component does. It still does something, but now it'll do something fancier than the original. I've decorated it somehow here. So if I run it now, it doesn't just say I did something. It also says we're doing something else also. So it says that, and then it does the original stuff here. So again, generally when you decorate something, it does the original stuff, but adds some more functionality to it for this. So this is our decorator component and how it's set up. If I look at the decorator component, again, it implements our interface. It has to store the decorated component. What is it going to be working with? It has to store that. And so when we call the constructor, we pass it in and we store that. So and that's how it knows, the decorator knows how to access the concrete component over here. We pass in the concrete component. The decorator calls that what did I call it? The decorated component. That's the component we're decorating here. So remember that. And now then we have to implement our interface here. So we besides calling the something method for the decorated component, we also do something else here. And so we just have a method that does something else here. So again, our something does the original something, but also decorates it. And again, very similar, like kind of the adapter pattern. Remember, we had an object in there, and we called functionality in that object, and then we had to manipulate it somehow, change it to something like that. Like we'll look at this week, on Thursday, we'll look at maybe we're writing to a database, but it is slow and it stops the interface because it doesn't do it asynchronously. Well, maybe we add a decorator to this, which will add asynchronous to it. So now we'll write to the database asynchronously, and it won't hold up the user interface there. Or maybe we'll add better, logging or do some translation to this in some ways. So there are different reasons why you can, add some functionality to some component for this. Now, the original code in the textbook lays this out. Again, they have their concrete class that implements the I component and does something. Theirs is just blank, which I thought was very boring, so I added the print line statement. They added the decorator component that implements the interface, stores the decorated thing here, and again, it calls something and something else, which in the code does nothing here, and then they call the original do something here. And in the main program, they have this interface here, and then they create a new component. Their component is a new, and they did create the decorator component, and right away they just instantiate the concrete component in when they're calling the constructor, which is a fine way of doing it. I've just broken it up to a couple lines. In fact, if I were writing this, I'm not a fan of static variables. I would move these things inside our method here, and then we don't need them to be static. I don't think I like this is how I would illustrate it. I would say here's our two components, the original component and the deco component. We instantiate the concrete component as the original. We instantiate the decorated component, the deco component, and we pass it in the original component. And then with the deco component, we can have it do something here. Questions on this? So, um, again, the textbook doesn't cover too much on this. So I have a couple other resources. Uh, this do factor factory stuff has a nice little thing on they have a lot of C# patterns here for you to look at here. So here they have something like the decorator component and they have a UML class that tries to show it again. So they have some component, they have a decorator that implements that component here. And sets this up, and they try to work through the code of this. So they're actually decorating two different components. They have two different concrete components here. I find this example a little complicated. Here, this one is a little better, I think, when they get to a real world example where they're working with videos and books, and they have this borrowable interface here. I guess yeah, or they're working. I guess they're working with a abstract class and not an interface here, and so they have this library item and things can be there. So, um, this one, the source making, I think I like this one a little better, here. Um, where again they start with a basic window and then they add features to that window in different ways here. So they have a widget and they add border decorations to the widget. I don't know if any of you have taken the mobile apps class, and we did Flutter in that class. Yeah, right. And Flutter, you have these widgets, and all you do is add widgets around them. So if you want to, yeah, have a text field and you want it to be centered, you don't change some property, say centered. You just add a center widget decoration around the original widget. And if you want it to be, a box around it and blinking, you add a box component, and you add every widget decorates other widgets kind of like that. And again, that's where this kind of shows up, is that we have a window or we have a decorator, we can add borders, we can have scroll bars to this sort of structure for this stuff. So that that reminds, and again, you can see that decorator component in that. So uh, okay, so let's go and do the next pattern. So again, decorator pattern is useful, and in some ways, I think the composite pattern is something you probably have seen more of and is a little more powerful, I think. But again, very similar there. Um, so again, we're going to have an interface that's going to do something there. Um, we're going to have a leaf object, and again, this is like our concrete object that does something. But we're also going to have a composite object here. And unlike the adapter where we just had one object, the composite is going to maintain a list or an array of objects there and do something on all of those objects for it. So again, they're kind of showing this for loop for child in components, call child dot do something. So it's going to call do something for all of its children here, and it works through the code. Let me grab that code here. I haven't opened that up yet. So I'm going to grab that code, bring it into Visual Studio here. So again, we have an interface called I component. And again, it's probably not going to be called, it's just they're just making some generic interface. So this could be like we've seen with other things, I inventory or an I displayable, I borrowable interface, or an I, orderable product interface. Uh, Here, it could be any interface. We're just going to call it generically I component, and it's just going to do something there. So everything that implements I component has to have a something method. And again, our leaf node is just like our concrete node. It implements the interface. And it just says for something, it just writes lines, leaf. This is an elm leaf. So just here's a generic leaf here for this. Um, Now we could have other types of leaves. We have a second type of leaf that implements the I component interface, and it does something. And so this says leaf two, and this is a birch leaf. And then we have a third type of leaf here, class a third leaf type. It implements interface. So since it implements interface, it has to have a something method. And again, it says leaf three. This is a maple leaf. So we have our three leaves here that each print out something different for this. So now our composite component is going to store a list of these children here. So it's going to have create a list of I component objects here. So everything that goes in the list has to implement this interface here. Um, and we're going to have a method say add component and another method called remove component. So add component, we're given a component and we add that to the list. We say remove, we're given a component and remove it from that list here. And here's our collection. Now we're going to make this somewhat generic in our collection. So rather than saying it's a list, we're going to say it's an I collection. Again, I collection is just a generic version of like a list or something like that. So we have our list of children. And then again, we're implementing the interface. So if you implement the interface, you have to do something. So we have our something method, and it just goes through, not leaps. It leaps through all the children. No, it loops through all the list items. So for each variable child in children, child dot do something. So it goes through the list and tells each child to do something, each item in its list of children objects. So again, that's what they're kind of showing here, our textbook. And our component, we have our leaf. Our composite has, again, they show the components and they have this kind of bracket kind of showing it's an array or something like that of objects. We're using a list rather than an array in the code there. And then it's do something, it's showing it goes through for each child and components that calls that child do something. So that's what it's trying to show here. Here. And again, you can kind of see this one to many interface here that a composite object can hold multiple inner objects that implement the interface. So how would we use this? So in our main program, we're going to create a component A, and we're just going to say a new leaf. And then we're going to create a new composite component here. So create a composite component. That's basically our list of leaves. And then we can just add a leaf. We can say composite that add leaf here. And we can we can create a new leaf. We can take a second type of leaf, a third type of leaf here. So now we have three leaves for this. Um, and so then we can say, and again, so this component, so like a normal component, here, we'll just do this for the normal one. I'm gonna delete all this stuff for now. So if we're just doing with one leaf, we create a new leaf and we say leaf dot do something here. So that will just say, I'm an elm leaf, leaf one, I'm an elm leaf. So we can create a single leaf and do something with it. But we can also create, again, a composite object here. And we can have add multiple leaves to it. So B is going to have multiple leaves to it. So now we can see when we do the first one, we just get an elm leaf. But when we do the second one, it has an elm leaf, a birch leaf, and a maple leaf. Here it's made up of all this. So component B is made up of this composite object for this stuff. Now you're thinking, Tom, that just seems like you have an object that's an array of other objects. That doesn't seem very satisfying there. But what's interesting is that our object that is an array of other objects implements the same interface as a single leaf. So one of our complex objects implements the same interface. And our array is an array of those objects of that interface type there. So here, I created this composite object here. I can add that to one of my other objects here. So I could make a new object like a new composite object. I'm going to make a new composite object. And so I can add lots of things to it. I can add a new leaf to it. I can also add the whole composite object before. So I can build a hierarchy. So composite 2 includes a leaf and all of composite, the first composite one to it here. So I can add and I can do oops, I wanted that. I can build it up where now this, I can make a complex composite object that's made up of other objects here. And when I can run this, I can have it, it'll print off all these things. Oops, that should print off more because I'm just going to have it actually do something with the most complicated object, the composite 2 object. I'm just going to do something with that. And it'll go through the hierarchy and print out all the leaves that are in this hierarchy. So once we have this structure set up here, we can create kind of this sort of stuff. We can have a client that has a composite object that could have leaves in it, and it can have other composite objects in it. And those composite objects can have leaves and other composite objects, and that composite object can have other leaves. So it lets us build this sort of complex structure. And this is where you'll see like file systems are built this way, where you can have a folder and inside that folder can be a file or another folder, and inside that folder can be files or other folders. Or you're doing an inventory system or something like that, and you can have an object in inventory and maybe inside inventory you can have a package and that has its own inventory inside of it, and you can look inside that here for this. Or, again, you can see the imagining selling products and having a storefront. So you can have a product, but maybe you have a a group of products that go together in some case or some set or some promotional activity, and you can add that whole promotional set to the shopping cart in the same way you can add an individual component to the shopping cart. And again, so when you're checking out, you're going to be like printing out the price or calculating the shipping costs or the weight or something like that. And so your composite object knows how to calculate the weight by getting the weight of each of its subcomponents or getting the price and summing the price of each of its subcomponents here. So you can use this sort of structure in lots of ways here. So that's what this is trying to show is this sort of structure here. And again, it just all you need is you need this composite component that implements stores an array or a list or something like that of the subcomponents, and it creates a list of the same interface that it implements. So it implements an interface and it creates objects that implement that same interface. So then it can kind of do this recursive stuff where we can take a composite component and put it inside another composite component without any problems. And again, then when it's doing something, all it's doing is going through each of its children and say do something for each of its child objects. So, okay. There's a couple other versions of that. So here's this Do Factory version of it. Here talking about a component that has a leaf and has a composite component in it here. And again, in that compositive component, it has, it's doing a for each children do whatever operation. So it's implementing some operation and the composite is doing that. And each leaf knows how to do the operation, but each composite object knows how to do that operation for this. So now you can do this with or without interfaces. Some of these things talk about doing this without interfaces. Today, these things are almost always done with interfaces here. So here's this other one from SourceMaker talking about this, an interface and then a leaf and a composite object that both implement that interface here. Now, again, they have a method called do this, and they have an add element method. And again, they talk about doing a for loop to call do this for each of the composite, each element in this list. So they do this arithmetic computation one, again, where you're building expressions, an expression tree, and how you build an expression. So you have an operator here, and they do it there for this and set this up. So. Okay, so I think those are two interfaces or patterns. I think they're not so complicated, and I think they're quite powerful. I mean, now it lets us, the decorator pattern lets us add functionality to an object without changing the original object there. And the other one lets us, again, kind of create this hierarchy of objects that all implement this it's always that place where the customer says, "Oh, well, I have this object, this thing. Can I put a package inside a package?" And you're saying, "How would I do that?" Well, and then you think, "Oh, yeah, it implements interface. I can just use this composite pattern to let you put a package inside a package or whatever you want to do with that." Okay. I'm going to go over one more, this decorating the logger idea. So again, the book also goes into a couple other things. It talks about this predicate decorator. I'm going to skip over that stuff in the text here. And they talk about logging decorators, and that's what we're actually going to talk a little bit about and look at that sort of idea They have a profile. They're just showing it some different examples of what kind of decorators you could do here for this stuff. Uh, so let's look at the logging one here. So I'm going to open up this example. Let's try that again. And again, you can do this. This is actually set up as an assignment. We used to do this in class before I moved to the asynchronous stuff. So you can bring this in and modify the code yourself if you want. So this is back to our currency trader. This is an older version of our currency trader for this. Um, and we are going to change our logger. I don't know if you remember, we have a simple logger here that logs the information to a console here. So inside currency trader, we have a logger class uh, that logs this item in. Um, and it implements this interface iLogger for this. So again, we're implementing an interface with the logger. Now, right now, it just writes the information out. And where you want to change this, so it also saves the log to an XML file for this. So where's our console logger? Here. I was looking, here's our console logger. Uh, And the console logger, again, implements the interface and it just does these write lines here. It actually, and I've modified to write to an XML file here, but I really want to, I've modified it directly. A better way would be to do it as a decorator class here, where we'd add this information to the console login for this. So oops, I clicked on the file. So for our logger class, we have our console logger, which just logs this stuff. And we want to create another logger that adds some functionality to this. Look at this. Uh, Yeah, I was doing the GUI stuff, but I moved away from the GUI stuff. So we're gonna implement this interface by creating another object here, a logger XML file for this. So I'm gonna go in here, I'm gonna create a new class. Where's my new add class? And I'm just gonna call this like XML logger, something like that. I called it logger XML in the example. I'm going to follow that logger XML. And like console logger, this is going to implement the iLogger interface for this. And if we're going to do a decorator, we're going to pass it in a logger here. So we are going to create a yeah, that looks like a constructor there. But the constructor we're going to pass in an I logger to use that we're going to decorate. Um, so we're going to pass in the original logger. We're going to have to save that. So we're going to need a variable here, an I logger, and we're going to call that original. And then in our constructor, when we're passed in the original logger, we're just going to save it into our local variable. So our logger implements this interface, and in the constructor, we're passing in a logger for this. Now, we haven't implemented the interface, so I'm just going to click here and say, quick actions, implement the interface. It's going to add the methods it needs. We need two methods, a log info and a log warning there. And so both of those, we're just going to initially, we're just going to call, not throw an exception, but call our original logger and say call log info. And again, we've got to pass in our log info, pass it our message and our arguments. And again, when we call log warning, we're going to just use our original logger. And we're going to call log warning. And again, pass our message and our arguments. So far, we haven't decorated it all, but our new XML logger will work just like our original logger here. We'll pass in the original logger, and when we say log info, it'll log the information the same way. And now I'm going to add, and so I'm going to go into this console logger and take out this XML stuff because I put it in here and I should have put it in the logger, I think. So I'm just going to put it in here and log this. So besides logging the information to the console, I'm also going to write it to this log file. And same here, I'm going to take this and put that in here. So again, now my XML logger, we give it the original console logger. It calls log info. The log info method calls log info for the original logger there, but the decoration is that it has it opens up our log file, our XML file, and logs the information to that also. So it saves it to the log file as well as to this. This is really common, decorator, is to add some more additional logging or auditing or security. So a lot of times, like you may not have security on a database, and so you'll add a decorator to add security where you'll verify the user information before you allow them to access the database or write to that or something like that, or add some functionality to it here. Now, where would I use this? So in my main program, where's my main program? Here. Right now, I create a logger and I pass that to a couple different methods here. So what I would want to do now is I would create a new logger. Uh, um, and so I'm going to create this console logger. And now with my logger variable, I'm going to say, I'm going to do a new, not a console logger, but a logger XML. and I'm going to pass the console logger into that. So now the rest of my code just expects the logger, so I don't have to change anything else. I'm passing this new logger to my other methods, and it implements the same functionality. So I don't have to change that code. I don't even have to change how I pass this to it. I'm just I'm just creating a decorated version of my logger here. So I'm taking my original logger and passing it into the new console log or XML logger. So it knows how to log to the console, but also will decorate it with XML for that. Make sense? So just another illustration to this functionality. And again, the book goes over that and a number of other ones here. So they talk about decorating properties and events here. So far, we've only been really working with method, like an interface with a method that's implemented. Like here, we're decorating the log warning and log info. Now in C sharp, we can also have properties in our interfaces here. And so we can decorate our properties and maybe adjust what the properties are doing for this. Uh, so we might have a property and we'll just return the decorated properties property here. But again, we might tweak it a little bit and change maybe its type or something like that here or do some component of it. And same with events. We really haven't, I'm not going to go over too much events, but event handling, you can add decorators to events here. Okay, so that wraps up this unit. We're finally done with chapter 7 here. So what are we going to do on Thursday and stuff? So, well, we have our guest speaker. Is Clara coming? Yeah, Clara's coming. Anyone remember Clara? She was only a 2022 grad. Some of you should have been here when she was here, maybe. I think she was the TA, or was Owen the TA? There. Well, anyway, she's at Skirion now. So we'll talk. She's only been at Skirion for 2 years now. So we'll talk and see how she's doing there. So okay, so we'll talk to Clara on on Thursday. We'll also we'll take a little deeper dive into asynchronous tasks and stuff like that, and look at reading information asynchronously and stuff and that sort of stuff. So we'll add that. I'm going to say this sort of we'll talk a little bit more about asynchronous tasks. Well, maybe let me cover this now because again, we have Clara coming. Because usually last year we covered this all on Thursday, but we didn't. So let's just briefly talk about asynchronous tasks. So what do you know about asynchronous tasks? Have you seen those other places where like I think we do it in mobile apps where we would have to we call some method and it takes a long time, so we're waiting on that method, or we get some special version of the variable while we're waiting for that there. So again, it used to be we had to actually generate a new task and run it. We'll actually look at doing that the old-fashioned way on Thursday. That's what we did last week. But there are new ways of handling asynchronous tasks. And again, any sort of task you do that's going to take a lot of time, like a second. No, you're thinking second's not that much time. But in the computer world, if you have a user interface, a second is going to take a lot of time there. If your computer freezes up for a second, you are going to be upset there. Trust me. You might not think so. You will be upset there. So anytime a operation is going to take a second or more, we're going to put this in an asynchronous task. So it's going to be running in a background task or a separate task than our main UI task for that. And there's different ways of doing this. In C Sharp, we have something called an await, where we can await an operation here. So here's our long process. We're saying the long process started when we just make the long process sleep for 4 seconds, and then we say long process completed, and we have some short process here. And then we talk about how we can do these things. So here, what we're going to do for our long process is we're going to await it here. So it should allow us to do other things while we're running this here. But it'll hold up this code often and wait for this to happen. So I guess it, I don't want to say it's waiting for this to happen, but it's also putting it in another thread here and that thread is waiting it to happen. So again, when we do it this way, where we just say long process, short process, the output will be long process started, and then we'll wait and we'll wait and wait, and it'll say long process completed, and it'll say short process started and short process completed there. It's all synchronous. But here, when we stick in the await here, we'll say long process started, but our await will start up another thread to do the rest of this, and it will keep going back, and the short process will then run. So then we'll see short process started, short process completed, and then we'll get long process completed there. Because again, of this await says, push this out into another thread. So everything so the rest of this method is in another thread at that point for this. So there's these commands await and async there when we and task, and we'll be manipulating those. So anytime we put an await in a method, we have to make that an asynchronous method. So like up here, we have static void long process, and there wasn't anything there. But now when we add the awake, it's static async long process. So anytime we say async, this is going to be, await, our method has to be declared asynchronous.
For methods that are asynchronous but have a return, do you have to wrap them in a task?
Right. Yes. So that's our next thing, is that if we have our task here that returns like an init long process returning an integer, now that integer has to be wrapped in a task there. So we say async task. And again, that what we're going to see is we're going to have to manage that task. So again, we're not getting an integer, we're getting a task there. Now, C Sharp has a task wrapped around it. What has the future? Java? Does Java have a future wrap? I think Java has future wrapped around it, saying this is going to be a future integer, and it's not an integer yet. But again, most languages have some way of wrapping some thing around these objects to say this will be an integer in the future, or it's a task that's going to generate an integer for that. So here's our asynchronous task that does something. So again, we have a public task, run things asynchronously. It has to have an async in it, and rather than returning an integer, it returns a task. Okay, go vote. Good job. That returns an integer here. And again, we're doing our long process, and our result is not an integer, but a task that it returns an integer. At some point, we want to maybe actually display that result. So we are going to await that result. And so this will stop this section of code and won't run this section of code until we can convert that task that's going to generate it into an actual int So we'll add an await here for this. Now when we run things, we will run our launch process and it will generate a task, but it's not returning an int. It's returning a task wrapped around an int here. So, and then we can wait on that task uh, to get the results for this. Microsoft has this breakfast example here where they talk about, like, I don't know, they're trying to talk about a simple example where you're making breakfast. Anyway, so I made a breakfast. I put some toast in the toaster today. So I did that first because I know that's going to take a while. And I hit the toaster. But while that's going, I can grab my bowl of cereal and pour my cereal in it and go get the milk there. So it can be doing multiple things at the same time while you're waiting on one thing. And so they talk about this and not being what we call IO bound here, where again, your interface will freeze up while you're waiting. So again, here we're maybe waiting for this to get something from a web client there, and we don't want it to, our whole interface to uh, kind of freeze up. Yes.
So I just kind of looked in the example that we
Yeah.
put up. It was like variable something equals await in the method call. Is that the same thing as like doing it like task string data equals that and then like string equals awaits that kind of thing? Like
Yeah.
is that just a short
The string, the await will take something that has like a task around it and wait for that task to get done and convert the return. So it'll convert like a task integer into an integer.
So you can do it on one line like that.
Yes.
Doing it.
Right. Yeah. So, um, here's here's breakfast synchronously for this. Let me just grab this whole thing and run this. Get the right URL to clone this. Okay, let's see if we can run breakfast synchronous.
There's that.
Oh,
Yeah.
yeah. Oh, this is not going to work. Okay, we won't worry about this. I haven't updated this code. I didn't think we'd be coming to say. So, well, I'll wait. I'll run this on Thursday, and we'll talk more about these asynchronous tasks on Thursday. So Thursday, we'll have a guest speaker, but we'll have you work through this learning activity where we'll use decorator pattern to add some asynchronous stuff to our get trade data method for this. And we'll also talk about how some more about unit testing for this. And then for your assignment, again, you'll make something, the database stuff asynchronously here. And we'll talk about having to what we have to modify to get the database to work asynchronously and call that for that. So we'll do that on Thursday. So. Okay, I'm going to wrap up today.